The next plenary talk is on fusion of statistical and computational thinking and its application to fuzzy cluster scale statistical analysis by Professor Mika, Sato-Ilic, Faculty of Engineering, Information and Statistics, University of Tsukuba. She holds the position of professor in the mentioned institute, and she was vice president in National Statistics Center of Japan, quite a famous center, and also currently occupied the position of special counselor and services as a member of a committee in the financial services agencies in Japan. She is the founding editor-in-chief of International Journal of Knowledge Engineering and Software Data Paradigms, and also the associate editor of several of the journals such as Activity Transaction on Fuzzy Systems, Neural Computing, Information Sciences, and the regional editor of the International Journal on Intelligent Decision Technologies. So she was counsel of the International Association for Statistical Computing, a series of the International Statistical Institute, ISI, and elected member in the ISI, and the country representative for the Committee for Women in Statistics in ISI. Also, she is a senior member of the IEEE association. She served the various committee, including in as the vice chair of the Fuzzy System Technical Committee of the IEEE Computational Intelligence Society. IEEE committees, including the Administration Committee and Program Co-Chair and Special Session Co-Chair of numerous international conferences, and she published four of the books and 14 book chapters and over 150 journal and conference papers. Her research interest include the development of method of data mining, multi-dimensional data and data analysis, multi-mode, multi-way data theory, pattern classification, and computational intelligence technology for which she has received several academic awards. So we can enjoy her talk. So thank you very much to join us, Professor Sato-Ilic. Please
thank you.
Start your talk.
Okay, so can you hear my voice? Okay, all right.
Yeah.
Okay, Thank you very much for your kind introduction. And first of all, I would like to thank Professor Watada for inviting me for such a nice opportunity to talk about my research today. So I would like to talk about future of statistical and computational thinking and its application to fuzzy cluster scaled statistical analysis. So in 2018, 48 leading researchers and educators gathered at the National Science Foundation in the United States to develop a 10 to 20-year vision for the field of statistics. They made 3 goals. The first is identifying emerging research topics that require new statistical foundations, methodology, and computational thinking. So nowadays, we have a lot of large-scale big data through physical, social sciences, medicine, engineering, finance, industry, and governance in many fields, such as biological processes, precision medicine, decision-making, policy planning, climate change, economic and social behaviors, and risk assessment. However, statistics has created a discipline for learning from data, even if data-driven scientific paradigm becomes a new norm. However, statistics need to transform their own field and play a leadership role in data science. In this time, we have to consider interplay between statistical thinking and computational thinking. So if we think about the interplay between statistical thinking and computational thinking, people tend to think about statistics versus artificial intelligence. So artificial intelligence is defined as an ability of a machine to perform cognitive functions, including perceiving, reasoning, learning, and problem solving. So examples of technologies of this AI are robotics, computer vision, language, and machine learning. So well-known algorithms, deep learning, is an algorithm of this machine learning. Then let's think about the timeline of this machine learning. The beginning was the least square method for regression in 1805, proposed by Legendre, which is a statistical framework in data fitting. And then after it, Butler wrote a book entitled Elephant, whose title of chapters, The Book of the Machines. Also well-known Turing machine, Alan Turing wrote a sentence that I propose to consider the question, can machines think? In his article entitled Computing Machinery and Intelligence. This is our first beginning sentence he wrote in this article. So first is a least square method, which is a statistical framework in learning from data. And after it, the Butler considered whether machines develop consciousness, or Turing said, can machines think? And after it, artificial neural network, including perceptron, was proposed in 1958. Backpropagation was proposed in 1986. And CNN, which can be used nowadays either in deep learning, was proposed in 1989. Also, SVMs for natural language processing was proposed in 1992, and deep learning models were proposed in 2006. And well-known IBM Watson and AlphaGo were implemented in 2011 or 2017. So if we consider like that, there is no difference between statistical thinking and computational thinking in the framework of learning from data in data fitting. Then this is an example of the calculation framework named BOMB to decrypt Enigma messages at 1940s. So this is an Enigma machine manufactured in 1944, which is used for communications between U-boat division of the German Navy and its naval bases in Second World War. And this is an advertisement of the Alan Turing Institute, established in 2015. They mention Alan Turing's pioneer work in statistics is considered to have laid the foundations for modern day advances in data science and artificial intelligence. In fact, he made an algorithm named BAMP, which is statistical sequential analysis by using unit named BAM to measure information. So there is no distinguish between statistical thinking and computational thinking. This is a fusion between them. So second and third goals were engaging with important data-driven challenges in collaborations and creating a research community. People tend to say basic research is statistics and data science in application domains or applied research. Such a distinguish between basic and applied researches exist in the conversation between Socrates and his student Glaucon in 400 BC. Socrates said that what about taking up astronomy in our next studies? Then his student Glaucon said that would be wonderful to think about the importance for warfare, agriculture, and travels at sea. However, Socrates says, you disappoint me by your short-sighted views on knowledge. But both Socrates and Glaucon are clearly interested in knowledge. These are the equally important different ambitions behind work in science. In fact, OECD has distinguished researches over basic research and applied research and experimental development. And based on such an idea, there is a linear model of innovation. So first we create basic research, and based on this research, applied research exists. We develop something, manufacturing, marketing, and sales. And such an idea came from Bush's statement in 1945. However, if we read carefully about his statement, he said, if government needs strong industrial research, then they should support basic research and develop scientific talents. So nowadays, we have the chain-linked model in 1985 and research related with any kind of phrase. For example, analytic design, test, produce, and distribute and marketing. Also, we have a knowledge production mode, and this first mode is related with basic research, and the second mode is mainly related with applied research. So they are not independent with each other. They are interact with one another. So this is a fusion between basic and applied research, and related with today's my talk, this is a fusion between statistical and computational thinking. Nowadays, society is much more complex, so we need mode 3, which is multi-level systems of knowledge. So, sorry. Now, this is another example of the changing skills of the requirement for actuary from 2016 to 2019. So in 2019 and in 2016, either the statistics is a higher skills as a requirement for actuaries. However, such advanced analytical techniques such as forecasting or statistical modeling are rapidly increasing from 2016 to 2019. So we need confusion between statistical thinking and computational thinking to deal with complex and large amount of data. Okay, so in 2002, approximately 50 statisticians from around the world gathered at the NSF to identify the future challenges and opportunities for statistics profession. They made 6 important challenges for the 21st century. The first point is scale of data, and the second point is the data reduction and compression. Third is machine learning and neural networks, and fourth is multivariate analysis for high dimension and low sample size data. And the fifth is Bayes and biased estimation, and the sixth is the middle ground between proof and computational experiment. So today, I'd like to talk about our recent researches in the framework fuzzy cluster scaled statistical analysis related with these 6 points. The first point is scales of data. So growth in data has been exponential. The growth of data analysis is quadratic. For statisticians, it is linear. So we need theory of scalability, robustness, as well as the tips of scientific understanding of data. The second point is data reduction and compression. Such an idea already exists, such as sufficiency, conditional argument transformations, and asymptotic optimality. However, we need new ideas in the areas such as model selection, prediction, and classification. So principal component analysis is a well-known statistical data reduction method. The purpose of this method is to obtain the result in lower dimensional space. This figure shows 11 objects in higher dimensional space, and the black dot shows the result of the principal component analysis in 2-dimensional space, which is this plane. Then we can see these 2 results are close to each other. However, in fact, they are so far from each other. To overcome this problem, we include the result of fuzzy clustering of objects in the higher dimensional space to this conventional principal component analysis to obtain more accurate results. The third point is machine learning and neural networks. So we have a lot of strong methods in machine learning and neural networks to deal with large and complex data. So we need to integrate such a method to statistics. Fuzzy clustering is a technique of machine learning in the area of computational intelligence. In this clustering, a fuzzy cluster is defined as fuzzy subset. So this is a Kushiro machine-learned satellite image data in Japan. The gray zone shows machine-learned area, and the pink zone shows mountain area. So we try to capture this machine-learned area as a cluster that is a subset. Then, by using ordinary set theory in mathematics, then subset is defined by using such a characteristic function. That is, if a pixel belongs to this subset, then the degree of belongingness is 1, otherwise it is 0. However, in fact, such a boundary area exists in which each pixel is not perfectly weighted, and at the same time, this pixel is not completely dried either. So if we try to capture such a boundary area, then we need many clusters. To overcome this problem in fuzzy clustering, we allow each pixel has the degree of belongingness to cluster from 0 to 1 by using such a membership function. Then considering the status of belongingness of object to clusters, we can adjust to real-world situation to the clustering. So if we observe many image data, then the number of data is huge. And if we just take minimum and maximum values as an interval valued data for each pixel, then we can reduce huge amount of data, but at the same time, we will lose information of data. To complement the lost information, we include a clustering of objects in higher dimensional space. And this is a result of the first principal component analysis when we use ordinary clustering. However, this is a case when we apply fuzzy clustering. Okay, so we integrate fuzzy clustering as a method of machine learning to the conventional statistical analysis, which is the principal component analysis, whose purpose is data reduction. Then we can obtain more accurate results when compared with ordinary clustering case. Okay, first point is multivariate analysis for large P, small n. That is a high dimension low sample size data. In this data, the number of variables is much larger than the number of objects. We need to develop new multivariate analysis for this type of data, and this is current research importance of this subject across many areas of statistics. So this is microarray data from GNN, which is consisted of 12,626 variables which are kinds of genes, and 32 samples, including 23 cancer samples and 9 healthy samples. So this is a typical high-dimension low sample size data. So if we apply the conventional co-clustering to this data directly, and this is a result of heat map, we cannot see any clear classification results. However, this is a case when we use fuzzy clustering, then we can see slightly distinguished two clusters. And this is a case when we apply fuzzy clustering and interval representation in symbolic data analysis, which is a core analysis of statistical learning in computational statistics. Okay, then we successfully divided into two groups, a group of cancer and another group of healthy data. The first 100% discrimination successful example was leukemia data, which is consisted of 6,870 variables and 38 samples, and this paper was published in Science in 1999. Okay, this is a base and bias to estimation. If data has the huge amount and large numbers of variables, what's going on? Okay, can you see my slide?
Okay.
Sorry, something happened.
No. Thank
Is
you
that
very
all
much.
right?
You have something more minutes. Is it okay?
Oh, yes. Oh, can you hear? And then I didn't
May
start
I ask
anything.
the question?
Oh, sorry. I still continue my presentation if possible. And then you don't have any time. Sorry,
No,
I didn't, stop
30 minutes,
anything.
including a question and answer. So
Oh.
if you will stop this time, I
Sorry.
ask the question and answer 10 minutes.
Oh,
Usually
sorry.
not so many questions will
Oh.
happen.
Oh, okay, Professor Watada. I didn't stop by myself. And then someone stopped it. So if possible, can I continue my presentation?
Okay. So
All right. So can you see my slide right now?
Yeah.
Okay.
Okay. May I ask the question answer from audience?
Oh, no. If possible, I would like to continue my presentation.
Yeah, please continue.
Okay, all right. Okay,
Yeah,
so here's...
Sure, the 8 minutes are remaining.
All right, okay. So here's the base and the bias estimation, and we need the bias estimation. All right, so essentially, this is the solution space of fuzzy clustering when the number of cluster is 2. And the UIK shows the degree of belongingness of an object I to a cluster K. So from these conditions, the solution only exists on this line. And then this is the dissimilarity from object which has a clearer classification and then to this. And then this dissimilarity is larger than this one. So this one is from an object which has an uncertainty classification structure to this point. So if we will use such a fuzzy clustering-based dissimilarity, then we can distinguish object that which has a clearer classification. So this is a result of PCA based on fuzzy clustering-based classification. Then this is an object of without cancer, and this is a group of objects with cancer. So we include fuzzy clustering as a method of machine learning to PCA, which is a conventional statistical method whose purpose is data reduction. Our target data is high dimension low sample size data. Then we can reduce the number of dimensions from 12,626 to 3, and we clearly distinguish into 2 groups. This is a result of ordinary PCA. Obviously, we cannot see any classification, and because in this case, theoretically, we cannot obtain correct eigenvalues. So He6 is a middle ground between proof and the computational experiment. So today, I talked about our recent research. The image data is quite large data. Our target analysis is principal component analysis, whose purpose is data reduction, including interval valued data representation in symbolic data analysis. Including fuzzy clustering as a method of machine learning and integrated this result to conventional principal component analysis, we can obtain more accurate results for big data. And also another data is microarray data, which is a high dimension low sample size data. In this case, even if we apply the conventional principal component analysis to this type of data, but we can't obtain correct solutions theoretically. So including fuzzy clustering result and also utilize the bias of this fuzzy clustering to conventional principal component analysis, we can obtain the correct solution for the distinguish between 2 groups. Okay, cluster scaled analysis means we exploit cluster-based scaling to conventional analysis in order to obtain more accurate results or results in which we can't obtain using ordinary analysis. This is a philosophy. So Aristotle says there is 2 kinds of individuals. The first order individuals, such as the force or the man, represented unit in the world, that is the statistical population. So brown false, black false, white false. This is a target of this statistical population. However, there are different kinds of individual exist that is second order individual because we have concept of force. So we have a concept of a force. And this is a second order individual such as a force, a man, represented unit in a class of individuals. So we believe that we can utilize such classes of individuals to deal with nowadays complex and large amount of data. Thank you very much. Thank you.
Thank you
I
very much.
finished. Yes.
Okay, so we have 5 minutes. Do you have any question or comment from audience? Please hand up by using the reaction button. May I ask you the several question? You are.
May I ask a question to
of
the
course,
speaker?
please.
This is Gopal. This is Gopal from Anna University. Ma'am, as you would appreciate, we have gotten into the statistical analysis and it has established itself. The idea of computational methods is known, but however, it has always been shelved. What would be the reason? And if we bring in the computational method, how will we assure the norm, which is so nicely visible in statistics?
So I would like to make sure your question is statistics has a limitation. So that's why what kind of that we can deal
The plus,
with that.
the plus of statistics is that the norm becomes very obvious. That is a huge gain in the statistical methods.
Mm-hmm.
The norm, the bell curve, majority of people or majority of the exercise is falling here. The norm, the peak is obvious. We don't have to explain. Whereas in a computational model, it is not so obvious. So the transition is very difficult in a social system. The transition from a statistical method to computational method is very difficult.
Okay,
so how do we
yeah.
manage that?
Yeah, actually, if I understand your question correctly, and then you would like to talk about the clear solution of mathematics and also the solution of statistics or computational method. So of course, we don't have the clear proof sometimes because of the completely different the mathematics. The statistics has to deal with the uncertainty and also the other computational techniques that need to deal with the uncertainty of the real world exist. So we are targeted data. It's not the very clear structure such as the mathematics is targeting matter. So sometimes we didn't have the clear answer as a result, but I think nowadays the data science is has to be deal with the extraordinary data analysis. That because of the essentially our target, the situation has a complex and uncertain issue exist that still the people cannot discover well. So based on the measurement of the statistical tool over computational other engineering tool, that we now try to make the clear metric to measure what kind of the phenomena exist in the data structure or what kind of the data exist, the data structure exists. the inside of the latent structure of the observed situation. So that was something like we are now the process on it. But of course, merit exists because of the so long history. The statistics has a contribution, or other data analysis has a contribution to deal with the something, the data in society. So of course, contribution is so that's why that we try to discover the such a matter. So that was a little bit different from the clear mass analysis, but I think that this is very general issue. The all over the data analyst, not only the statistics, but also the engineering side of the data analysis.
I have two questions, small two questions.
Yes.
You showed the classification of data size. So
Yes.
but we used to use big data mining, big data analysis. Some people tell trillion size is big, but how much do you the scale included in big data?
Yeah, that was something like a common conversation that usually discussing about the big data. But I think that someone said in the big data analysis.
Not your opinion.
Oh yeah, I think maybe if people think about this is big, then this is big. If something like the people think about that this is the tall man, then oh, this is a tall. And then I think that because of the no boundary of the amount of the data, that we have to consider this is a big or this is not big, and then the theoretically or explanatory that we don't have any definition of this issue. But the model, the big, not big, I think that the large amount of data makes more data structure complex itself is an important issue. And also
next question.
Yes.
Question.
Yes.
You work on multi-mode and multi-way. Would you the multi-mode, multi-way data? Would you explain briefly? We do not have much time, so would you make me understand the multi-mode, multi-way? What is the multi-mode? What is multi-way? Is it the application is a multi-way? Or the multi-mode, I did not understand multi-mode.
Okay, so actually in my talk today, I didn't say about the multi-mode and the multi-way data analysis, but I understand your question, so that's why I will answer. And the mode meaning is the quality of the data, the direction, and the way is a direct direction. So for example, if we observe the 3D computation, over the object, then the object itself is a quality. So this is a single mode. However, the three kind of element was communicated to each other to obtain the 3D correlation. So in this case, the number of weights is 3. Otherwise, if I showed about the, for example, in my talk today, all right, so number of variables and also number of samples. In this case, we have variables and samples. So to qualify different the data structure exists. So number of mode is 2. And also the way is variables and the samples way exist. So number of the ways.
Anyway, thank you very much. Very interesting presentation.
All right, sorry, I'm not so satisfied. Yeah, all right. Okay.
Okay, we would like to move to the next the presentation. Next is the plenary talk. The title is on some fractal approximation method by Professor Bhagwati Prasad Chamola. So before presenting his plenary, I would like to introduce his